All right, everybody, we are moving on to 4.6 day 1. Today, we're working more with fractional exponents to radicals. You can go ahead and try this warm-up on your own. There are a ton of different ways that you could write these answers. They could all look different. So our shared lesson says that a radical is an expression that contains the radical symbol. It can be easily mistaken for a square root, but it can also be described to use a cube root, a fourth root, or higher depending on the index of the root. So we practiced with it a little bit yesterday, but we have a few more examples here. The fourth root of 81 is 3 because 3 times 3 times 3 times 3 is 81. Cube root of 8 would be 2. Cube root of 64 would be 4. So a few different examples and a couple of different ways that this could look. So yesterday we did practice with fractional exponents, right? The denominator becomes the degree of the root and the numerator becomes the exponent. And so yesterday it was always 1. Today we are going to work with it when the numerator isn't always 1. So as you see here, the numerator still becomes the exponent and the denominator still becomes the degree of the root. But obviously right here, you have one where the exponent's underneath the radical and one where the exponent's outside the radical. And that really doesn't matter. You'll get the same answer either way, but we're mostly going to just take the exponent to the outside and do it at the end because it's going to be easier. And what I mean by it's going to be easier, if I look at the example here, 16 to the power of 3 over 4, 3 goes outside, 4 goes to the degree of the root. I find the fourth root of 16 first, and then I cube it because that gives me to 2, and 2 is easier to cube. If I were to take the exponent first and do 16 times 16 times 16, so take it to the power of 3, now I'm looking for the fourth root of 4,096, which is a lot more difficult to figure out. I don't actually know off the top of my head that the fourth root of 4,096 is 8. So it makes it a little bit easier for us if we just find the degree or the radical, the degree of the radical of the root first. So the fourth root of 16 is 2, and 2 to the power of 3 is 8. So it's easier if we take the radical first and then apply the exponent. So we're going to go ahead and practice that today. So I have 8 to the power of 4 over 3. I'm going to put the 3 to be the degree of the root. 8 goes underneath, and the 4 can go to the outside. So when I take the cube root of 8, I get 2. And 2 to the power of 4. 2 times 2 is 4, times 2 is 8, times 2 is 16. A little bit easier. So 25 goes under the radical, 2 goes to the degree of the radical, and 3 goes to the outside. So taking the square root of 25 first gives me 5, and 5 to the power of 3. 5 times 5 is 25, times 5 is 125. Makes it a little bit easier instead of taking 25 to the power of 3 and then trying to find the square root of that. It's going to give us a really large number, so it's a little bit easier if we just take the degree of the root first. Okay, let's keep going. I have 1 to the power of 3 over 5. 5 becomes the degree of the root. 1 goes under and 3 to the outside. The fifth root of 1 is just going to be 1. 1 to the power of 3 is still just going to be 1. So nice and easy. Let's rewrite this. 10,000. I'm sorry, 1,000, not 10,000. So cube root of 1,000 is going to be 10. 10 to the power of 4 is going to be, now it's going to be 10,000. So again, obviously stressing this a lot, it's going to be easier to take the degree of the root first and then apply the exponent. If you apply the exponent first, you're looking to 1,000 to the power of 4, finding the cube root of that. It's a lot of zeros. All right, we're practicing with our powers of powers again. So we have k to the power of 2 over 1 times 5 over 3. We're going to get k to the power of 10 over 3. And let's go ahead and rewrite this to be the cube root of k to the power of 10. All right, n to the power of 5 over 3 times 5 over 4. We're getting n to the power of 25 over 12. 12 is the degree of the root, n is under the radical, and 25 is the power. That's all we have for today. Like it says, rewrite your exponent using only the numerator. Rewrite each fractional exponent using the denominator of the exponent as the root, and then simplify as needed.